everybody, today we'll discuss about the second part, which is deal completely with linear mixed model. And those who are new for this tutorial, I suggest you to take a look at the first tutorial, which deal about our data type as well as the linear model. So let's assign here, as all of you know, that the mixed model is composed of one is the fixed effect, the second one is the random effect. So I consider here genotype is one of my factor, green is a response variable, or GY is a response variable, while the case block is considered as random effect and genotype is considered as a fixed effect. So in order to use a mixed model, we have to use the LMER function. So our data name is TDZ. The default, the restriction maximum likelihood is just the default is true, but I said here is false because for model comparison. So type this and submit to your studio, and both this and as well as this model will yield the same result. You can use alternatively green yield as explained by 1 plus genotype and including the random effect in this way, and you have to indicate your data name. Even you have to add this into this one in order to for model comparison. So type this or this one, so you can use either of the one which is yield the same result. So let's check the summary of our model. Sorry. So as you can see, it will create also the correlation among the fixed effects, and we will get also the p-values for each genotypes. We have 12 genotypes. Among that, this genotype is highly significant. So the rest are not statistically significant because their p-value is greater than 0.05. And furthermore, you can also get the ANOVA for the genotype. For the genotype, even here it suggests that the genotype is not statistically significant different. And even you can compare also using different techniques, but the traditional one, that means the honest significance difference test, is not working here because this is a mixed model. So among the methods that we are going to use is the emins, which is built in the emin package. So type this, and also you have to indicate the T2 is our model what we create here, and the comparison is pairwise, and the things that we are going to compare is using the genotype. So and the method that are going to adjust using the take method. So type this and submit to our studio. Yes, so there is pairwise comparison, and all of are not statistically different within each other because their p-value is greater than 0.05. Yes, we already get in the ANOVA table, so we will not expect any significant result among the treatment. And the other model that we created here is assigning genotype as well as block as a random effect. And here is our data name is TDZ, and restriction maximum likelihood is false, because why I make false here is because for model comparison. So type this and submit to our studio. Then also we can get their summary in this manner. Yeah, again we will also do for model comparison for both the T2 and T3 models. So for here we have to use ANOVA, and we have to separate the two models using a comma. So T2 and here is T3. So let's see what ANOVA will give to us. So over here, as you see, there is AIC, there is BIC. That means AIC stands for Akaike Information Criteria. The second one is BIC, that is Bayesian Information Criterion. So you have to select the least one. So comparing to T3 and the T2, T3 is less than that of T2. So we have to stick to this model, So even for BIC, also for Bayesian, also T3 is smaller than that of T2. Furthermore, we can also add the location and the year as as random effect. Over here, as we already incorporated genotype and block as random factor, but here is genotype is considered as fixed factor, and block, location, and year considered as a random factor. But here is our data name is changed from TDZ to T. T is the original data that contains location, year, block, and genotype in all combination. So type this and submit to our studio, and we also compare with another one. That means with the site. For example, here is the LMR function. Genotype is as explained, granular as explained by genotype, and the random factor is block, location, year, and the interaction between location and year, the interaction between location and genotype, and the interaction between year and genotype, and lastly the interaction between genotype, location, and year. So 1, 2, 3, 4, 5, 6, 7 factors considered as random, and only the genotype considered as fixed. So type this and submit to our studio. So in similar fashion, we can get also the result in this way. Yes, the result in this way. And again, we also compare the two models, which is best. So let's see, ANOVA mode 1, which is considering block, location, and year only, but the model 2 is considering 7 factors as a random. So let's compare the two modules. So over here is 3675.5. So module 2 is better. Even for over here also the Bayesian is selected 3730, but mostly you have to prefer to use AIC. So in the case of AIC, this one is smaller, but in the case of BIC, this one is smaller. So you have to stick in the Akaike Information Criteria. So I select in the AIC the module 2, but in the BIC you have to select the module 1 is best. And furthermore, you can also subset each year, and you can also go for the analysis. In order to do that, you have to assign any name that you want, and you have to use GY as explained by genotype, and here is location and block, and our data which colors to T. So if you type this, and again you will get another result. So let's see the summary. So it also gives you different result that of the previous one. Furthermore, if you want to estimate the variance component, you have to use the print function in the var core for the module 3, and the component is a variance, so it will give you similar information. So this is all about the mixed model effects, and those who have a question regarding to my tutorial, you can address me through YouTube comment box, or alternatively you can use my email address. So thank you for watching and have a nice time.